Let's look at some graphs of common functions that you will be expected to know. Suppose I have a function y equals a. The first thing you always want to look for a function is what are your x-intercepts and what are your y-intercepts. Well, clearly this one has no x-intercept because it's just a horizontal line. The domain is all x's from negative infinity to positive infinity, but the range is just from a to a, so this is a point. What about a line? Y equals x. The domain for all lines is negative infinity to positive infinity, and the same with the range. What about parabolas? Well, for parabolas, you need to find where that vertex is. The domain for all parabolas is from negative infinity to positive infinity, but the range will be from the vertex on up to positive infinity. Cubics are a lot of fun. We'll use them a lot in calculus. Their domain is also from negative infinity to positive infinity. Now, don't let it bother you that the function seems to die off here. You're not seeing it in your window, in your calculator, because it's going up so very fast. Similarly, the range is from negative infinity to positive infinity. As a matter of fact, if it helps you, put a little arrow there to show you that it pops off to infinity. Now, what about the square root of x? Well, we need x to be positive. And this is going to be, it's going to start at 0, 0, and it's going to curve up like this. Now, the domain is from 0 to infinity. It doesn't go up as fast as the other functions we've been looking at, but it still goes up. And there is no maximum limit, and we'll discuss what that means in calculus, to this function. And the range is from positive infinity, from 0 to positive infinity, and these do include, both of these do include 0, both the domain and range. Now, the absolute value function is a wonderful function. One way to write the absolute value function is, this is the square root of x squared, and you will be ahead in calculus if you recognize that. The domain is all x's, but the range is from 0 on up to positive infinity. And let's look at y equals 1 over x. Now, the domain cannot include x equal to 0. So we will make this an asymptote, and other than x equals 0, it can include all x values. The range is all y values that don't equal 0. You see, as x gets very, very large, this is going to get very close to 0, but it's never going to hit or cross it, either in the positive or the negative direction. Now, what about the log of x? You do need to understand and be able to graph the log of x. It has an x-intercept of 1 because log of 1 is 0. As a matter of fact, that's usually the first thing I graph, and then it goes up. And as you go back towards 0, and we're going to discuss why this happened in the calculus, this becomes very close to this y-axis. So the domain is from 0 to infinity, but it can never equal 0, so this is open. And the range is from negative infinity, because this, you can tell this just shoots right on down to infinity, and then up to positive infinity. Conversely, e to the x can never be 0, so its range is from positive, or from 0 to positive infinity. Now, when x is 0, y is 1, because anything to the 0 is 1. So that's where my x-intercept is. And I know it's going to go down until it approaches 0, and then shoot up at infinity. And we're going to do a whole unit on this. So the domain is positive infinity to negative infinity. While if I put in e is negative x, the domain is again negative infinity to positive infinity, and the range is from 0 to infinity. The last thing you need to know is the sines and cosine, your trig functions. Both of these have domains from negative infinity to positive infinity, and the range from negative 1 to positive 1. The thing that really changes here are the x-intercepts and the y-intercepts. So make sure you can mostly remember your trig functions.